الثالث من المحور الثالث لمادة نظرية الآلات Theory of Machines. We'll continue here with different types of instantaneous center of rotation. So the instantaneous center, if we can see here, for this mechanism called 4-bar mechanisms with link 1, 2, 3, and 4, the instantaneous centers I12 and I14 are called the fixed instantaneous centers as they remain in the same place for all configurations of the mechanism. Here, 1.2, it is the center of rotation between link 1 and link 2. And it is fixed to link 1 and link 2 both. Known that link 1 is fixed to the ground, so I12 is fixed also. So it is called fixed instantaneous center of rotation. Same thing for I14. So the configuration of the system, if link 4 make rotation or link 2 make rotation and link 3 move, I14 and I12 remain in the same place. The instantaneous centers I23 and I34 are called permanent instantaneous centers as they move when the mechanism moves, but the joints are of permanent nature. I23 and I34 are called permanent. Okay? So the instantaneous center here, I13 and I24, I13 here and I24 here, are neither fixed nor permanent instantaneous centers as they vary with the configuration of mechanism. Okay, they moves. Okay, depending on the configuration of the mechanism, the 4-bar mechanism. As a note, so the instantaneous center of two links, such as link 1 and link 2, is usually denoted I1, 2, and so on for other links. So it is read as I12, not I12, be careful. The first two types, fixed and permanent instantaneous centers, are together known as primary instantaneous centers of rotation. And the third type, which is here, I13 and I124, sorry. So they are known as secondary instantaneous centers. How to find number of instantaneous centers in mechanism? Number of instantaneous center n is equal to small n multiplied by small n minus 1 divided by 2. So n is number of links. How to find location of instantaneous centers? Let's see here some examples. Between link 1 and 2, for the example A, this should be the instantaneous center of rotation I12. For the example B, here, we have link 2 rolling for the link number 1. Link number 1 is fixed to the ground. Okay? So if we take point A and point B fixed on the solid link 2, okay? So VA should be perpendicular to AI, and the same thing for B. Okay, the contact point between the roller and the ground is the instantaneous center of rotation, and we use this formula. So VA divided by VB equal I12A divided by I12B. Third example here, a pure translation for a solid slider link 2 about the link 1 fixed to the ground. So VA, we can remark here, VA is parallel to VB. So both perpendiculars should be parallel also. Didn't intersect, and then the instantaneous center I12 will be located at the infinity because it is pure translation, no rotation is there. Example number 4, we have a slider here, but rotational slider making rotation about the ground link 1, which is fixed. So by the same method, VA, VB, we make the perpendiculars to VA and VB. The intersection needs the instantaneous center of rotation. Okay, it is I1, 2. Last example. Also, we have a rotational slider, but externally. So the instantaneous center of rotation should be the center of the grounded link here, link number 1. And by the same method, BI12 should be perpendicular to VB, and VA should be perpendicular to AI12. Now, we'll see Aron-Holt-Kennedy theorem, our colored three centers in line theorem. So the Aron-Holt-Kennedy's theorem states that if three bodies move relatively to each other, they have three instantaneous centers and lie on a straight line. Let's see this example of 4-bar mechanism. We can remark here that I24, I23, and I34 for the link 3, we have these three instantaneous center of rotation in the same line. Okay, same condition and same example for I12, I23, and I13. Also, we can see the same for I14, I34, and I13. All the three are on the same line, straight line.